The title of Section 3 is Extracting Energy from Biomass. We spent some time describing how autotrophs make energy in the form of glucose in a process called photosynthesis. So plants and algae, which are examples of autotrophs, provide a molecule that gives us energy. And this energy is glucose. But how do we use that glucose to make energy? Well, organisms, in order to release and use the energy, we have to break down glucose. And the most common and efficient method for extracting the energy in glucose is a chemical reaction that happens in every cell of our body, and it's called cellular respiration. Here we have the chemical formula for cellular respiration, and we can break it up into reactants and products. Some of these reactants and products will be familiar to you. So the reactants are C6H12O6 and O2, and the products are CO2 and H2O. From our discussion of photosynthesis, we know that C6H12O6 is the chemical formula for a molecule known as glucose. And we know that O2 is the formula for oxygen. CO2 stands for carbon dioxide, and H2O stands for water. We have a table below that summarizes the reactants, the starting materials, and the products for cellular respiration. The chemical formula for cellular respiration is not totally different from the chemical formula for photosynthesis. In fact, it contains all of the same molecules. What's different is the order in which they are presented. So for photosynthesis, glucose and oxygen are the products. In cellular respiration, they are the reactants. And the same is true for carbon dioxide and H2O. For photosynthesis, they're the reactants, whereas for cellular respiration, they are the products. Now, this is not only coincidental, but this explains the interconnectedness between ourselves, organisms that use glucose, and plants and algae, producers that make glucose. So in order to burn the energy, we first of all need glucose and oxygen, and we get both of these products from plants. Plants provide us the starting materials. We take in these starting materials, a chemical reaction happens, and we release energy. And this energy is used by every muscle in our body, every brain cell in our brain. But we also release some waste products. In making the energy, there is some waste, and the waste products are carbon dioxide and water. So if you exhale, what you're releasing is carbon dioxide, and that carbon dioxide came from cellular respiration inside every single cell of your body. Water is released from our body, water that is produced from cellular respiration, and it's either released through our skin, through perspiration. It could also be released through urination. Now, the products that we produce, carbon dioxide and water, are special because plants use them. They're the starting materials for photosynthesis. So our end materials for cellular respiration are the starting materials for photosynthesis. And the end materials for photosynthesis are the starting materials for cellular respiration. These two processes are said to be complementary. They complement each other. One provides what the other lacks. Now, carbon dioxide is found in our atmosphere, and it's an important gas, and we call it a greenhouse gas. And the reason we call it a greenhouse gas is because a greenhouse gas is one that prevents heat from leaving the earth. And this is actually important. Greenhouse gases are important to our climate. If there were no greenhouse gases, our planet would be too cold to live. So producing carbon dioxide is a normal process that needs to happen. When we have carbon dioxide in the atmosphere, what it does is it increases the temperature of the atmosphere. Examples of greenhouse gases include carbon dioxide, methane, and water vapor. Without these gases, the Earth's average temperature would be around 0 degrees. So that would be the average. That means that if you were to average out the high and the low temperature, the middle ground would be 0. Now this is too cold for some animal life and too cold for some plant life. This diagram here demonstrates what happens when solar energy reaches the surface of the Earth. So the sun shines its energy down onto the Earth, and most of it bounces right off of the Earth's surface, especially if the surface is covered in ice or water, because both of those materials kind of reflect sun's energy. Now, some of the energy from the sun goes back into outer space, and it's not used by anything on Earth. But we need to use this energy on Earth. It needs to be absorbed. And one way we can keep it is if we reflect it. And the greenhouse gases do a really good job of reflecting most of the heat from the sun and keeping our planet warm enough to sustain life. Now, carbon dioxide, though it's found naturally in our environment, has been rapidly increasing. The amount of carbon dioxide gas that's in our atmosphere has been rapidly increasing, and this has posed a problem. If you take a look at the first graph, it shows the concentration of carbon dioxide in our atmosphere over time. And we see this J-shaped curve. This upward curved slope tells us something really important. It tells us that the amount of carbon dioxide in the atmosphere is not only increasing, but it's increasing exponentially at a really, really fast rate. So it's not a straight line, it's an upward curving line. And this J-shaped curve means it's increasing super fast. When did this increase start? If you take a look at the graph, the increase started around this time right here. The early 1900s or the late 1800s. And this is a really special time in history. This is a special time in history because around this time we discovered that the Earth contains fossil fuels. And these fossil fuels are really valuable. They're valuable because we can use them to power things like machines and cars, which people were just starting to invent. So around the early 1900s, the late 1800s, there was what we call the Industrial Revolution. Industries were born, and industries required the use of fossil fuels. So from that date in history, we started using fossil fuels. But now the amount of devices, machines, and factories that require fossil fuels has also increased exponentially. So we are releasing a ton of carbon dioxide into our atmosphere. So if carbon dioxide is a greenhouse gas and it traps the sun's heat, if we have too much of it, then too much heat on our planet is not necessarily a good thing. So it's like the greenhouse gas effect, but an enhanced version of it. And the enhanced greenhouse gas effect is a bad thing. The enhanced greenhouse gas effect causes global warming. Our planet's temperature has been increasing since the Industrial Revolution. What effect does this have? Well, there are several effects of global warming. The first is rising sea levels. Because of global temperatures increasing, polar ice caps are melting. If ice melts, the water returns to the sea. As a result, sea levels rise. Now, this is a bit of a problem because the majority of our populations, the majority of our big cities, are located in cities on the coast. So think of Manhattan, which is surrounded by water. If this increases, If sea levels rise, the way scientists believe it is, most of our major cities around the world, some of the homes to some of our greatest populations around the world, will be covered in water. People will have to displace themselves, move to areas of higher sea level. So let's write a little statement about this. Rising sea levels will affect cities and populations on the coast, forcing people to move. Now, we mentioned the melting of polar ice caps. Polar ice caps are important because they keep some of the water on the planet frozen. But in addition, polar ice caps are habitats for certain animals. For example, polar bears spend most of their days traveling and hunting across ice. When the polar ice caps melt, this means that polar bears have less land to hunt on. As a result, they have to travel through water to find more land. And the closeness of an adjacent polar ice cap becomes farther and farther as all the ice in the Arctic begins to melt. And for the first time in history, polar bears have been known to drown from fatigue from trying to find more habitat. So, not only are we going to displace ourselves, but rising global temperatures will be displacing any organisms that live on ice. So in summary, polar ice caps provide habitat for organisms such as polar bears. If the polar ice caps melt, then we have a reduction in the habitat available for these organisms. Now, you've heard this expression before, climate change. But what does climate change mean? We notice changes in our climate, but we need to notice changes in our overall average global climate. What scientists have been noticing with this enhanced greenhouse effect is not that there are storms and floods and hurricanes and rising temperatures, because we've always had historically floods and hurricanes and rising temperatures, but an increase in the number of them and the severity of them. So not only are we having more frequent hurricanes, but the size of the hurricanes have been increasing. The level of severity of these hurricanes have been increasing. So this is a big problem because along with some of these climate changes, we find effects on populations. So a hurricane can destroy the homes and destroy the habitat of humans. It can destroy crops and the food supplies of humans. Okay? These are very big world economic problems as a result of climate change. So in summary, we can write, an increase in the frequency and severity of storms. So what can we do about all this carbon dioxide that we're producing? Well, there are certain things that the governments around the world have established. The first was the Kyoto Protocol. Now, this is a very big topic of discussion, especially during election time, because not everyone in Canada agrees with this whole Kyoto Protocol. This is an international agreement signed by over 180 countries to reduce carbon emissions or get credits for removing carbon from the atmosphere. So countries need to agree to stop emitting carbon by increasing the amount of public transportation, by building HOV lanes, by offering money to people who want to convert to solar energy or wind energy. These are ways to stop emitting carbon dioxide. Now, there are also ways to remove carbon dioxide from the atmosphere. For example, planting trees. Since trees take in carbon dioxide for the process of photosynthesis, this reduces the amount of carbon dioxide in the atmosphere. So another way to reduce carbon dioxide in the atmosphere is to protect any existing forests in our country. When you cut down a tree, it is no longer available to take in carbon dioxide from the atmosphere and make sugar and oxygen. So trees are a big part of many industries, including the pulp and paper industry and the lumber industry. Now, these industries can still exist, provided that we make the forest sustainable. For every tree we cut down, we need to plant 5. This will ensure that our populations in our forest, our plant populations, stay high. And finally, at the community level, we can do things such as recycling. Less energy is needed to make something from recycled materials. Therefore, less carbon is emitted into the atmosphere when we use recycled materials. Our discovery and use of fossil fuels since the Industrial Revolution has caused another problem to our ecosystems. And this problem is called acid precipitation. When fossil fuels are burned, nitrogen oxide and sulfur dioxide are released into the atmosphere. Now these gases, when they're mixed with water, they produce nitric acid and sulfuric acid. These acids eventually return to the earth in the form of rain, sleet, or snow. And the pH of these forms of precipitation is lowered, and the precipitation becomes acidic. This phenomenon is called acid rain. In this diagram, we can see factories releasing sulfur dioxide and nitrogen oxide into the atmosphere. We see them mixing with water in the atmosphere, forming nitric acid, sulfuric acid, and returning in the form of rain, snow, or sleet. So we said that this type of precipitation is acidic. And we said that this type of precipitation has a low pH. pH is a term that you might not have heard before. pH is a scientific term to represent a scale. And this scale ranks substances on how acidic they are. So let's take a look at the pH scale. The pH scale identifies substances as acidic, neutral, or basic. The pH scale goes from 0. Right in the middle of 0 and 14 is the number 7. And the number 7 is important on the pH scale because number 7 is when substances are neither acidic nor basic. They are neutral. So what's an example of a neutral substance? A neutral substance, an example would be water. Pure water has a pH of 7. Now anything with a pH below 7 is considered to be an acid, with 0 being the lowest value or strongest acid, and 7 being the highest value or weakest acid. pH stands for the power of hydrogen. So in each of these substances, scientists can measure the amount of hydrogen that's present. And this affects whether or not a substance is either acidic or basic. If a substance has a pH that is higher than 7, any pH from 7 to 14 is described as basic. So we have listed a few substances. We have listed a few substances that are acidic. These substances are battery acid, vinegar, rainwater. These are all examples of acids. If anything has a pH from 7 to 14, we call these substances bases. Acids are acidic and bases are basic. So what are some examples of bases? Well, we have baking soda, we have ammonia, there is a substance called lye. Lye. And lye has a pH of close to 14. This chemical, if sprinkled on your skin, can dissolve your skin. Now, lye, which is known as sodium hydroxide, is used commercially. It's used commercially as a cleaner. So lye is used inside dishwashers. So if the rain that hits the earth is acidic, if we have acid rain, what effect does this have on our ecosystem? Well, number one, soil loses nutrients, especially calcium. Acid rain dissolves calcium from our soil, and calcium is an important nutrient in plant growth. Similarly, some plants and animals are really sensitive to this acid. So we have thick skin, and our skin won't burn if we walk out in the rain, even though the rain is slightly acidic. But some organisms that live closely on land and in water are really sensitive to acid rain. Fish, amphibians, and other organisms that live near water can't survive if the pH of the water begins to drop. For those of you who don't know, an amphibian is an organism that spends parts of its life in water and parts of its life on land. An example would be a frog or a salamander. So what can we do? What can we do to reduce acid precipitation? Well, the US and Canada have introduced laws to reduce emissions of nitrogen oxide and sulfur dioxide. We've improved technologies. We've added scrubbers to remove undesirable gases from the smokestacks of industries. We've also established the Ontario Drive Clean Emissions Test Program for vehicles. This ensures that old vehicles that are run down are serviced so that they don't release these harmful gases into our atmosphere.